So we actually came up with a pretty, well, what we think is a fancy name. The Hydroelectric Downspout Turbine replaces the rain generator idea. First off, I just wanted to say my name's Matt. I'm in second year chemical engineering.
And I'm Cole. I'm in second year mechanical engineering.
And I just want to say thanks for showing up and observing our presentation here. This is a good opportunity presented by Usiet. We're really excited about it. And we hope you have some interest in our project, and we definitely are ready for, if you guys have any ideas for us, we are glad to take them. All right, just what we're going to talk about. We'll go through a brief background, just kind of what we've come up with. We'll talk about how it fits with Usiet, our problem statement. Briefly, design specifications. We have dimensions and a fairly detailed design, but we won't go too in depth on it right now. Then we'll go through cost and timetable, and then we'll conclude. All right.
So for the background information, so as Matt had said, it's a hydroelectric downspout. So basically we're taking the concept of a dam, how they produce electricity that way, but we're applying it to houses or like downspouts on any type of infrastructure like that by taking the potential energy that rainwater has and producing actual electricity with that. So with net zero houses, there's many different ways for renewable energy, and in order to kind of get out of the fossil fuel or that type of energy sector, you have to take in all the possible renewable energy aspects. So this is going to basically work alongside solar panel, because solar panels do lose about 80 to 90% of their efficiency during a rainfall. So this is going to help out that loss in efficiency. So some of its uses are, like I said, for residential homes or commercial buildings that do have downspouts, and also for third world countries that don't have power readily available to them. They aren't on the grid or something like that, and sort of the rainforest or stuff like that where there is lots of rainwater. And also for camping or military, because this might not produce that much electricity, that in aspects like that where they just need light or to recharge their radio or something like that, then this definitely will help out with that. And yeah, as I said, to kind of make that shift towards renewable energy. And there's very little research in this concept, so it's kind of a new concept to use rainwater as a renewable energy source. So it's innovative in that way.
We kind of looked online, and most of the information we found wasn't, it wasn't scientific, honestly. It was just kind of throwing out figures and stuff like that. So that's part of it too. We want to actually research if it is a possible way to produce energy. So how it fits with Usiet. So I think obviously it's a renewable energy resource. We're excited about it, and we think that it'll be a good project for us to work through. We're kind of amateurs to this, so we're excited to actually start building something with the knowledge that we're gaining in engineering. We think it'll develop leadership skills, design and fabrication skills. So when you're actually making a project, you have to work through how to design whatever you're trying to design, and to provide an outlet for innovation and creativity. So like I said, we're really open to if anyone has ideas that they want to bring forward. We're still kind of in the brainstorming process. We've hashed out a lot of things, but I think that there's a lot of room for more specifics. And then the last thing, and I think this is kind of why this is such a good idea, it's really low cost. We'll get into that. Easily fabricated. It's not a super complex thing. I think it could be made in a pretty reasonable timeline. And then we should be able to test it on a reasonable timeline too. So that's the other element. So problem statement, our idea was to provide an innovative renewable energy source that's easily implemented, cost efficient, and doesn't disturb the environment. So this design shouldn't have there's no byproducts or anything like that. It's just, you set it up, maintain it, and it'll produce energy for you. Like Cole said, it's for small devices and for providing light. And yeah, it's a good learning opportunity for future engineers. So kind of so you know more of what we're talking about here and you're not trying to picture it. This thing will fit in the downspout on a commercial building or residential building. So on the right side there, you can see we have a filter, so that's to just prevent debris from falling into the turbine itself. we wanted to have a capture basin so that we can direct the flow specifically onto the Pelton wheel. And then we chose the Pelton wheel because it's the most efficient as far as our minimal research could discern. It works the best for low velocity and for liquids. We have ball bearings to control the rotation and to move into the brush motor. And then that's kind of where we get pretty, like, we don't know too much about the whole like brush motor, energy storage, or anything like that, but that would be something that hopefully someone could bring their expertise forward to.
So the cost table here that we have, so basically we want to make the grate that stops the leaves and other debris to be 3D printed. So it's like, because it's so small, it's going to be pretty hard to fabricate it yourselves. So that kind of is cool in that way that you get to learn how to use a 3D printer. We're not sure about the cost on that because we do know that there is 2 of them out here in the engineering building, but they're only for the other team, thank you, USST. So we're not sure if we have access to that yet, but once we find that out, then we'll know the cost better on that. Do we need a lumen sheet to make that downspout? So you can just get that from Home Depot. We found it'd be $50.
I'll just say quick, we want it to be able to be installed onto a downspout. So basically we'll build it within like a, I don't know, 2-foot downspout, and then you can just cut the downspout on a house and then fit that inside it. That's the idea. Anyways, go ahead.
Oh yeah, and then also the Pelton wheel will have to be 3D printed because they are kind of a complicated design, and it just maximizes the efficiency, the time efficiency, and cost efficiency. And then also the capture basin, because it has that kind of weirder shape on it, it's just easier and like for time and cost efficiency to do that 3D printing. Plus it gives you some experience with that. The aluminum rod that will like hold the Pelton wheel, we'll just get that from Home Depot, and it was a $10 cost. Brush DC motor that was like not sure exactly if the 36 volt, 24 volt type of volt is the best efficiency, but they like range in that $20 range. So whichever one's most efficient would be the one that we'd purchase. And then battery, like we said, we're not sure the best way like to put on the grid or battery, but for the testing period we'll just use a voltmeter, so battery's not like really necessary at the moment. And aluminum mounting bracket, we'll just use that from the sheet of aluminum. And the ball bearings for the rods, they're $5 each, so it comes up to $10 cost. So basically the project costs about $90, and then plus the 3D printing costs, however much that is dependent on the access to the 3D printer. So the timetable, so this is going to take approximately, we think, is 4 months, could be a little bit longer, could be a little bit shorter, but basically in month 1, we plan to talk to professors and other experts on the best way to maximize efficiency for both the Pelton wheel and the turbine, or I guess it'd be the DC motor. We also want to analyze the design to approximate how much energy it could actually produce, to see if it's really like more worthwhile to really go into that, or there's a better way to change up the design a bit. And then we'll do our final design, and then head into the second month by starting the fabrication process to actually create the Pelton wheel and all the other aspects of it. And then we want to start running tests in the second month to determine how much power it's producing. And then with that data, then we'll determine if it needs to be changed in the third month, and if there's other applications, such as in different temperatures or different environments. Like we were talking about, like since with like storm drain sewage, how like all the water comes to one point, if it could be used in that type of application to maximize the total power usage, in that type of aspect, or in other environments. Like
we were thinking like how it would handle snow too, like snow melt. I don't know, we'd have to work through that because we weren't super confident that this design would work for that. And then the other one we were thinking, and this was just today, it was kind of random. We were talking about like in a commercial, or sorry, like a factory or something like that, if they produced like liquid waste material, you could like somehow use that to produce energy too. I don't know, that was very brainstormy today, but it's possible.
Yeah, there's other applications that we kind of look at, and then we try to run those tests to see if these other applications are plausible. And then month 4, basically like make it market ready. So like make it so it has like a final design, final way, the best way to produce the electricity, and to basically if they want to use it in other environments, like they said in third world countries, if it's cheap and able to make it for them and stuff like that.
Okay, so Why the Pelton wheel? I kind of talked about that already. Cole actually talked to a TA instructor and a professor, and we were told that it's the most effective way. So, like I said, it's because it's the best on the z-axis for flow. It's for fluids with low velocity, and what was the other thing? Oh, right. The number of scoops, we want to maximize that because then it's going to get over like a steady flow. It's going to have more rotations, which I'm sure most of you know, or some of you know. Okay. So that thing on the right is the filter. We kind of played around with aluminum, or we would just fabricate it ourselves. And then the thing on the left is the capture basin. So this kind of shows the offset nozzle. So basically, just so that the flow is continuous and directed to one side of the turbine. Ball bearing and the DC motor. We looked online, and we think that we can just attach the DC motor directly to the turbine rod, and it'll just spin it directly like that. But again, we're not super confident with the electrical stuff.
Oh, also we were gonna say with the ball bearing is self-lubricating too, like the kind of we were looking at, so that we don't have to deal with stuff like that. That it actually
like you don't have to grease it.
Yeah, grease or anything like that. So.
Okay, to conclude, so we're kind of working with a design that's obviously it's not super innovative, but the way that we're implementing it is innovative. So we can apply it to modern and commercial buildings. They're getting rainfall down onto them, and we can use that potential energy to create electrical energy. Like I said initially, it's easily implemented, it's cost efficient, and it doesn't disturb the environment in any way. It fits really well with the mission statement, so it's a good opportunity for students to learn about the design process. And it inspires passion in innovative sources of energy. And like Cole and I were talking about, there's a vast number of applications, so just because maybe our design isn't the best or you disagree with something that's part of our design, we're willing to try out other things, and we're super open to that, which also fits with the Usiet mandate. So opportunities for you, if you're looking to join our team, you can be one of the first people to determine whether rain power is actually plausible as a renewable source, if it actually produces enough energy to be a possible resource. You can learn about 3D printing and other fabrication skills. Learn more about generators and power generation from turbines. You can learn about Pelton wheel, and I think like there was a design, or there's an ongoing design project about turbines, but this is another opportunity to learn that way too. And then this is kind of what I'm most excited about, is you can develop skills related to working on an engineering team and turning the ideas and concepts that you learn in class into actual physical solutions to problems. And hopefully this will actually be something that can be implemented and create real change in the world. I think that's everything. So thanks for listening, guys.
Thank you.
All right, if anyone has any questions, like, just fire them off. I'm sure
Yeah, go for it. Go ahead.
First, I absolutely love this idea.
Cool.
And the next is kind of, where did the idea come from? Like, is someone already doing this, or?
You kind of just came up with it.
Yeah, it was actually like a night of drinking, and I got pretty like soaked wet. I was like, man, somebody could totally make power with this, because like I saw, like I was looking outside, and my neighbors like they have like the wind like kind of generator outside, and it was just spinning like crazy because it was this like torrential downpour. It's like, man, somebody could totally make power with that. And so that was this kind of thing, and then I just talked to Matt, and then we found this team at.
It was kind of all like, it came together all at the same time, which is sweet. But
yeah, so it was really sweet. So
yeah.
It worked out like that. But that's basically the how I come up with it. Yeah.
It's not like super, you know, it's not going to create a ton of energy or anything. Like, we're not pretending it will, but it's nice to, like, you can create energy during periods of time when you probably wouldn't otherwise, right? Like, you wouldn't be creating solar energy during a storm. So this is just another avenue to create renewable energy. You had a question too?
Yeah, just a couple. So you said you're gonna put filters in there?
Yeah.
Which is the obvious, right? Yeah.
Yeah.
You need it because leaves and whatnot gets in there.
Yeah, for sure.
How would, you probably haven't gotten this far yet, but they would have to be taken out at some point, and it needs to be watertight, I would assume.
Yeah, so we do actually have, The watertight aspect, not so much, but we have a mechanism for removing the filter and cleaning it that should be pretty easy.
Because that would be a big deal if you got
Yeah.
blocked, right?
Yeah.
Essentially, the idea was just to create a sliding door, basically. And then you just pull the filter out that way. We haven't, like, we've talked about it, but we haven't worked through it.
Yeah.
My other question is just, does the system need to build up pressure to work?
The best way for a Pelton wheel is pressurized. Like,
Okay.
you know, the velocity hitting that part, like, is
Yeah,
like
the higher the
yeah,
velocity, right?
yeah,
So
basically.
would it be worth it to have some sort of a nozzle that only opens up after a certain amount of head has
Yeah,
been
that
produced?
is
Yeah,
that's a really good idea.
that's
And then
actually-
that way, even in low, like if it's just drizzling, it would just build up and then you get decent performance.
I totally agree.
That's actually huge. We've
We
never
were-
really thought about that.
We were kind of like trying to figure out how we could create enough pressure. Like you said, if it's not raining that much, it's not going to be that useful. But we
It
could
needs to
be
be like
Yeah,
Definitely.
it works best efficiency. The highest efficiency is when it has
full
the-
flow.
Yeah,
Yeah,
full
for sure.
velocity.
Cool.
Yeah.
Yeah, those are my own questions.
Go ahead.
So you guys had a team of 3. How big do you think this crew needs to be, or do you
Uh,
need a couple extra?
I think we definitely want someone who's like not necessarily in electrical, but is more capable than we are at the whole electrical side. I don't think we really put a number on it.
Like
to be
honestly,
honest.
like we're like however many people want to come, like you know what I mean. Like there's so much, like so like we said,
To
there's gonna be
cover.
aspects like look at it and stuff. Like to do research in that area too. Like if more people come up with other ideas on how it can be implemented in an environment, and then we do research on if it's possible to even come into that environment, and then run the tests on it. Like totally open to as many people as want to.
Yeah.
I mean, the fabrication, like I guess, like won't require as many people, but like it's still like to come out and try out like 3D printing stuff and do that type of like file
Yeah,
format and stuff.
try it
Like
out.
it's a great opportunity.
This is, I gotta say, really cool. It's kind of neat.
Cool.
And it's a very complete kind of thing. You can see the beginning, middle, and end. You can see this device, and you can see building 10 of them, which is kind of neat. You've gone down the design process fairly far. You know, like you've got some initial sketches and it's not. Do you think it might be worthwhile, or maybe are you open to kind of backing up and sort of restating the problem? You know, the problem is there's energy in this water. How can we capture it? Do you think maybe that might be worthwhile to kind of spit that out into the group? And maybe Pelton Wheel, maybe
Yeah.
there's something else out there that
Yeah.
these
Oh,
people-
definitely.
For sure, like-
we honestly we wanted to be able to present something
Yeah,
tonight.
okay.
Yeah, so that's-
that was part of it. We kind of just selected stuff that expressed our idea, but definitely we're willing to try other things out
'Cause
and
there's
start at the
a lot
beginning.
a lot of different ideas here that I can see a lot of creative solutions.
Yeah.
For sure.
Yeah.
Because there's a lot of potential energy in water. If you think about like how hard that's coming down, even hail or like snow and stuff like that, like it's coming down with the velocity. So there
Yeah.
is potential energy in that water, and we want to use that to make an eco-friendly
Yeah.
type of like maximize that like the
Yeah,
renewable energy
for sure.
sector.
I think it's kind of a new thing is like all these sky rises and tall buildings, you can use the height of those buildings to create energy, basically. That's the idea here. So, yeah. All good?
Is rust a concern with any of your parts? Like, I know you're
Yeah.
using aluminum, so that's not really too bad with like the joints and everything. And
That was kind of part of the reason we picked plastic. But yeah, definitely we have to like work through, you know, keeping it like watertight and like the rust part of it. And I'm not sure how long it'll last. Like it might last like a year, which probably isn't ideal, right? Like we'd want to maximize that as part of the design.
Yeah,
So
we'd have to look at the materials that they're using,
Yeah.
hydro dams and stuff like that, because obviously like they're not replacing parts that often, right? So you'd have to look at the proper materials to actually use for a project like this. So we'd look a lot closely at like the hydro systems, like in that retrospect that they have already up in the market. So
and then weight is an issue too. Like even if you're using like a capture basin and it's like at some level on your downspout, you can't have it being too heavy, right? Like it'll break your downspout, which is probably worse. So that's
we'll have
something to consider
Yeah, we
too.
have to take a look at all those type of different aspects
Yeah.
of it.
You know, maybe you could combine this with a rain gauge too, right?
Yeah.
Because, you know, implicitly you're measuring how much rain is. Maybe you
Yeah,
could
for
tweak
sure.
your rainfall to your own or something, right?
Yeah.
Yeah, that's awesome.
That's really cool.
Yeah.
I know there's Jim Bug, our department head, or used to be a department head. He put some solar panels up on his back garage about a year ago. And they have individual inverters on every single solar panel. and he has an app that runs on his phone. At any time of the day, he can go and check exactly the output on each individual solar panel. He can find totals for the day, totals for the year, averages. It's just cool.
Very cool.
It's awesome. Yeah, we definitely look at something like that.
That's what
Yeah. Right. All right. Good.
Thanks again.
Thank you guys.